Hello everybody. Okay, welcome to the next lecture of the subject controllers for automation. In our first lecture, we discussed the overview of the subject controllers for automation, and also we discussed the contents of each unit, and also we discussed the the types of controllers used in the industrial automation. Okay, and in the next lecture, Dr. Sridharan explained the fundamentals of PLC, the overall function of PLC, and how the PLCs are being used in the industrial automation for operating either a machine or the actuators, advantages and as well as disadvantages. So in this lecture, we are going to discuss the architectural features of PLC with the help of a simple block diagram. Okay, so as a mechanical engineer, we must know how to use the PLC for different applications. Okay, that is sufficient. Okay, for only the electronics and communication engineer and electrical engineers need the in-depth knowledge on each and every component of PLC. But for our mechanical engineers, only this block diagram is sufficient to understand the different components of PLC and as well as their functions. So this slide shows the block diagram of the PLC. So yeah, easily you can understand the major components of PLCs are CPU, central processing unit, power supply unit, memory unit, and input module, output module, and programming device. But of course, programming device is not a part of PLC, but programming device is necessary, essential part of PLC. Okay, we'll discuss the need or importance of programming device after completing these PLC architectural features of architectural features. Okay. So the power supply unit of PLC provides the power, or otherwise we can say it provides the energy to various components of PLC. Of course, depending upon the applications and design of PLC and the need of PLC, the PLCs with different power modules are available, like a 24 volt DC supply, 120 volt AC, 240 volt AC. But mostly in our industrial applications, especially for industrial automation, okay, we use 24 volt DC PLC. Okay. So major components of PLC are CPU, input modules, output modules, power supply, memory or data storage. We'll discuss the functions of each unit. So CPU is the central processing unit. It's a brain, okay, of a PLC, like how the CPU is functioning in the computer, because the CPU is the responsible for reading the instruction. Instruction is nothing but program, and as well as getting the data from the various devices like sensors, okay, and other data vision devices. So it executes the instructions given by the program, and as well as it consider the signals coming from the sensors, and then it will give the output. Okay, so we are going to discuss the input module and output module, okay, after finishing this CPU. So I think you can understand the function of CPU now. So it is the brain which actually essential to execute the program and as well as read the informations from the sensors for producing certain outputs to operate the actuators or machines. Okay, so the common functions of CPU in PLCs are programming, execution, data processing, communication, memory management, diagnosing the fault and handling them, and yeah, of course, it is used for real-time control. Timing, synchronization, security, and access control, etc. So the application of PLC is depending upon how the PLC is going to be implemented for controlling certain devices or machines in the industries. Okay. So memory unit, from name itself we can understand it is used to store certain data, certain programs, and etc. There are different types of memory in PLC system. First one is the program memory. It stores the PLC's operating system, that is OS, and firmware, antivirus softwares, and the user-defined PLC program, that is a set of instructions. PLC program is nothing but the set of instructions, and also it stores some logic functions. And the data memory, which actually used to store the values or the variables used in the timers, counters, and other datas relevant to certain input buttons, output coils, and etc. So input output memory is used to exchange the data between the PLC and the input and output modules. So some PLC systems offer the ability to expand the memory by having the external module or memory cards, like how we are using external hard disk in the computers. But these external memory modules provide the additional storage for storing the programs, data, and the configuration information. This helps the PLC system to handle larger and more complex applications. So, so in the very first slide we have seen the programming device is the very important element. There are different types of programming devices. Generally we use the computers, desktop computers or laptops. Sometimes we use very handy type of device called handheld device, like how the teach pendants are used in the robots to operate them. Here also we can use a small teach pendant kind of handheld device for writing the program. But nowadays these kind of handheld devices are observed, since the computers or the laptops are very convenient for us to develop the PLC program and store them in the PLC to execute them. So programming device, the program or instruction is written, and then using this device the program or instruction is stored in the PLC memory. So as I said earlier, so programming device may be a computer or laptop. So programming is performed using specialized software provided by the manufacturer of that particular PLC. So the PLC programming software is designed to run a computer operating system such as Windows. The software provides an interface for creating, editing, organizing PLC program, and also used for configuring the PLCs, especially input-output modules, and setting the communication parameters and other related tasks. So we need to run this software on computer, and it will allow us to create, edit, transfer the PLC program to operate PLC hardware for execution. So input and output modules. These input and output modules really not a part of PLC nowadays. Uh, these input and output modules can be designed, okay, and fabricated according to our requirement. That is, input and output modules are customized modules. Okay, so shortly we can say it as customized modules. So CPU or microprocessor can work with the 5-volt DC supply and it can deliver a very small output current or voltage. But the input devices or sensors work with the high voltage such as 12 or 24 volt DC supply. Okay, so to interface real world input devices and sensors with the microprocessor, okay, the input module is used. Here the input module always gives the 5 volt DC input signal to CPU. Okay, so another important point is that the microprocessor can work with only the digital signal, but all the input devices and sensor may not produce a digital signal. So obviously we need digital to analog and analog digital converters in PLCs. Okay, and in fact most of the sensors create the analog signal, and another important function of module is to convert the analog signal into digital signal. So microprocessor or CPU, central processing unit of the PLC, can deliver a very small amount of current, that is 5 volt DC output. Therefore we cannot drive the loads directly with the CPU of the PLC for operating the actuators in the industries. Of course, we need the output module with digital to analog device, okay, to convert the digital value into analog value and as well as to amplify them. Okay. So this slide shows the photographic view of the particular PLC. So yeah, this a purple color, okay, component is a power supply unit, and of course the top layer, okay, consists of the CPU module, okay, the analog input module, analog output module, okay, and the entire vertical component is the counter module, positioning module, and this vertical part is nothing but in the input module. This vertical part is nothing but the output module, and of course PLCs will have some dummy modules. We can make use of them as either an input module or the output module. Okay, so there will be one base unit, okay, on which this power supply, okay, the CPU, okay, input modules, output modules, dummy modules are okay simply fixed on them, on that. Okay. So next part of this lecture is PLC programming. Okay, so PLC programming is nothing but, as I said earlier, it is the set of instruction. Okay, and the CPU of the PLC will read the instruction and execute them for producing the outputs. But we use different languages for programming the PLC. Okay, some of the languages used in the PLCs are listed here. Okay, as per the IEC, that is International Electrotechnical Commission. IEC means, okay. So as per IEC 61113, it is the standard used for defining the PLC programming languages. Okay, so as per IEC 61113, okay, structured text programming method, simply called as ST, sequential function charts, SFC, ladder logic program, LD, function block diagram, FBD instruction list. But mainly we use the ladder logic diagram, because in early days the people used a big electrical panel for automating the certain operations, in which there are a lot of levers, okay, buttons, relays, switches, and etc. Physical devices. But it's a very big one, okay, very big one, and a very complicated one, okay. And later on PLC introduced, okay, these structured text sequential function charts, function block diagram, instruction list are somewhat difficult for the operators, okay, to use them as a programming languages to write the program and operate the PLC. But the ladder logic diagram is the very simplest method. It is easily understandable, okay, by all the, okay, operators, okay, of PLC, okay. And yeah, the ladder logic programming method, before programmable logic controllers became popular, as I said here, so relay based controls were the, okay, normal at most manufacturing sites, okay. So relays drove the loads based on the simple logic that was implemented through the physical wiring of the devices. So there will be a lot of wires and yeah, connections, okay, are there in the physical, okay, ladder electrical panels for operating the variation machines and actuators in the manufacturing, okay, sectors. So, as the most basic PLC were introduced into the field, the ladder logic PLC programming was designed to mimic the layout of the relay-based, the physical electrical circuit, so that even a layman or the operator, okay, can easily understand, okay, the programming method, okay, using this ladder logic language, okay. So, ladder logic programming, since its inception, ladder logic has evolved significantly. However, the basic principle of operation remain the same. Okay. So, ladder logic programming evaluates each rung of ladder in sequential order. Okay. Assess conditional instructions, and if the result evaluates to true, the output instructions are executed. So, what this second paragraph trying to explain is the PLC basically takes the decision and produces the output, okay, based on the logic, okay, especially true or false, okay. We'll discuss them in detail later. So the ladder logic programming method is the graphical method, okay. Okay, the symbols of various okay, components of ladder logic, like a start button, stop button, relays, timer, timer on delay, timer on delay, off delay, counter, okay, etc. are available in the available as a library. Simply we can pick them and drag them into the working window, okay, between the, okay, two vertical ladders, and assemble them. And yeah, of course, designating the function of the each, okay, graphical, okay, modules of this ladder logic programming is very important, okay. So we have to designate what is the function of start button, what is the function of, okay, coil, what is the function of delay, timer, what is the function of the relay, and etc. So we'll be discussing the programming of PLC, especially ladder logic programming of PLC during our practical session. So for understanding purpose, I have included this slide. Okay, so programming means here there is no any coding. Okay, here the ladder logic PLC program is very simple to understand. Okay, everything is in the form of graphics. Okay, so easily you can understand and write the program for operating that actuators or machines. Okay, so we'll be discussing the programming part, okay, in very detailed manner during our practical session. Okay. So the advantages of ladder logic programming, so very simple to implement, and yeah, easily we can troubleshoot the program. And ladder logic is a visual language. Okay, so there is no coding, as I said earlier, there is no coding that provides the confirmation of status for most instructions. In other words, it is easy for someone with little knowledge of a specific process to walk through the program and understand the logic, okay, without any difficulties. So modular design, ladder logic can be easily modified through the addition or subtraction of logic. Such rung is a separate condition and can be removed or added as a needed. So what this second paragraph try to explain is we can easily modify the ladder diagram according to the requirement at any time. Okay, so resilience and consistency. Okay, ladder logic allows the user to implement many functions. However, the language is heavily standardized and does not give full flexibility, thus keeping the code consistent between the different implementations. So there are some disadvantages of this method, ladder logic PLC programming. So steep learning curve, that is ladder logic is a simple language, yet not very intuitive to those who come with the backgrounds in C, C++, Java or higher level language like Python. That being said, it may be easier to grasp for electrical engineers, okay, compared to the computer engineers. Okay, it is easy for the electrical engineers and those with basic knowledge of assembly programming. And yeah, of course, PLC programming is the slow deployment because of the visual nature of the ladder logic. It takes longer a programmer to create the logic, okay, for executing, okay, different operations of industrial applications. So there is a need to drag and drop elements that slow down the development process versus other modern manufacturing languages. Okay. So however, when it comes to modern control theory that involves PIDs, flow control, analog sensors and feedback loops, it is not always easy to implement. Okay. So there are some constraints in PLC logic, ladder logic program.